Hi, my name's Rob Loney. I'm a solutions architect here at VeloCloud by Broadcom. In the next 15 minutes or so, I'd like to give you an introduction to VeloCloud SD-WAN, talk about the various VeloCloud SD-WAN components with a focus on scalability, resiliency, and flexibility. So who is VeloCloud? Well, the founders of VeloCloud understood that applications were moving to the cloud and that an enabler of that would be and is SD-WAN. So they came up with the phrase velocity to the cloud, shortened to VeloCloud. We are now the trusted SD-WAN vendor to both our service provider partners and enterprise customers. This is demonstrated by the fact that we have held a leadership position in the Gartner Magic Quadrant for 7 consecutive years. We service more than 18,000 customers with over 600,000 sites across 180 countries globally. So why VeloCloud SD-WAN? Understanding that applications were moving to the cloud, we designed a solution with simplicity and ease of operations at its heart. VeloCloud simplifies networks, enhances performance, and enables agility. Our purpose is to get users and devices to the applications and data wherever they reside, in the cloud, SaaS services, or on-prem as securely and efficiently as possible. We achieve this in a number of ways. Our smart defaults automatically recognizes more than 4,300 applications, categorizes them, and applies business policies routing them in the most efficient manner. Zero-touch provisioning allows for the agile deployment of edge devices at sites, delivering the ability to onboard a location in a matter of minutes. Our secret sauce, DMPO, or Dynamic Multipath Optimization, helps to ensure application performance with per-packet steering and on-demand remediation with techniques such as forward error correction, NAC, or negative acknowledgement, and jitter buffering. On-edge security is delivered with the onboard firewall, which now includes enhanced services such as IPS, IDS, and URL filtering. Now that I've talked about the why, let's discuss the how. So how does VeloCloud SD-WAN simplify and scale the WAN? Well, at the heart of the solution are 3 simple architectural components. 1, the VeloCloud Orchestrator, or VECO. 2, the VeloCloud SD-WAN gateways. And 3, the VeloCloud SD-WAN edges. 2 of the 3 components, the Orchestrator and Gateway, are hosted by VeloCloud ourselves. The VeloCloud Orchestrator is that single pane of glass in which all administrative functions are carried out, whether that's configuring the network, configuring security features, monitoring, reporting, or troubleshooting. It's all done from the VeloCloud Orchestrator. The second component are the VeloCloud SD-WAN gateways. Now we have gateways positioned across the globe in our own POPs. The gateways perform 2 important functions, one in the control plane and one in the data plane. From a control plane perspective, they act a little bit like BGP route reflectors in that edges in an enterprise will announce their local routes to the gateway, which then reflects those to the rest of the enterprise, thus building the routing table. In the data plane, the gateways act essentially as a transit to the cloud. As you can see in the slide here, the gateways are actually part of the SD-WAN overlay. So edges in an enterprise build tunnels to the gateways and then can use the gateways because of their locations in our POPs as an on-ramp to the cloud. And finally, the third element of the solution, the SD-WAN edges themselves. Now we have various different platforms, and I'll come into those in a second or two. But essentially, the edges build the SD-WAN overlay across whichever underlay is available, whether that's wired, wireless, public, or private. We're completely transport agnostic when it comes to the underlay. The edges build permanent tunnels, or spoke edges will build permanent tunnels to their hub locations and gateways, providing that connectivity to the cloud or to the data center. Spoke-to-spoke communication is on demand, so only when there is communication from one spoke to another will we build a tunnel between 2 spokes. Now, over the course of the last 12 months or so, we've refreshed our hardware platforms, starting with the 700 series. There are 4 models within the 700 series offering various capabilities in terms of throughput, tunnel count, and interface support. We scale at the lower end, 710, 710 5G, from 950 meg and 50 concurrent tunnels, all the way to 6 gig and 800 concurrent tunnels with the Edge 740, with an option in between, the Edge 720. The 710 and 710 5G models offer Wi-Fi 6, with the 710 5G having 5G capabilities. Both offer multiple 1 gig interfaces. Both the 720 and 740 models offer multiple 2.5 gig RJ45 interfaces and 10 gig SFP plus modules. Now, whilst these models are aimed at the branch, we have recently released edges aimed at the large enterprise or data center. So these are the 41 and 5100 models for large enterprises and data centers. They offer unmatched scalability for both large enterprise branches and data centers. They offer massive throughput up to 100 gig to support workloads at scale. As you can see on the slide here, the 4100 offers up to 30 gig throughput with a tunnel support of 12,000 concurrent tunnels. The Edge 5100 offers a massive 100 gig throughput and up to 20,000 concurrent tunnels. Both models, the 4100 and 5100, offer multiple 10 gig interfaces, with the Edge 5100 offering 4 25 gig interfaces and 2 40 gig interfaces. All the models I've talked about so far, the 700 series, the 4100 and 5100, are available as a high availability pairs, giving you redundancy at the hardware level. But how do we scale beyond a pair of high availability edges? Well, we do that using clustering. In VeloCloud, a cluster is a group of multiple SD-WAN edge devices that work together as a single unit. This provides scalability and redundancy, especially for large campus locations or data centers. Clustering is also a requirement for redundancy in hyperscaler environments due to their inherent lack of layer 2 functionality. Clusters are horizontal scaling mechanisms used to address the limits of single edge in terms of tunnel count or bandwidth. Up to 8 edges can be placed into a single cluster, with the cluster logically being seen as a single hub. Spokes are assigned to a single member of the cluster. In the event that the hub a spoke is assigned to fails, the spoke will automatically fail over to another cluster member. Clustering is an active-active topology, with all members of a cluster being active. The redundancy model is n+1, with n being the minimum number of edges to satisfy bandwidth or tunnel count requirements. Incoming SD-WAN tunnels are load balanced amongst cluster members based upon member load. There is no sync amongst cluster members, only a local BGP session which is used for exchanging information amongst them. On the slide here, you can see the process for assigning a hub cluster member to a spoke. In the first instance, or the first step, each member of the cluster sends usage stats to the gateway acting in the control plane. The usage stats includes things like load. The second step is that the spoke edge then requests from the gateway an assignment of a cluster member. The gateway, again acting in the control plane, runs an algorithm which assigns the most appropriate or the best cluster member to that edge in step 3. The spoke edge then builds a permanent tunnel to that cluster member, thus building that cluster to spoke to hub connectivity. But how do we scale beyond simple clustering? Well, we do that using cluster to cluster interconnect. Before release 5.1, clusters could not be hubs to one another. Cluster to cluster interconnect allows hub clusters to have a hub-spoke relationship with one another. It introduces a fundamental change in the SD-WAN routing protocol that allows packets to traverse more than one hop in the overlay network. We introduce cluster-to-cluster to address two common customer requirements. Firstly, to allow remote sites to communicate with one another without the need for a common hub location, thus reducing tunnel count overhead at both hub and spoke. And this is illustrated in the diagram at the bottom of this slide, where we have two spoke sites, one on the right, one on the left. They don't have a common hub location, a common cluster, but the cluster-to-cluster interconnect between those two cluster locations in the middle provides that spoke-to-spoke communication across that interconnect between the two clusters. The second requirement was multi-cloud support. Because the cloud doesn't support layer 2, virtual SD-WAN edges must be deployed as a cluster to achieve redundancy. In the past, this prevented an on-premise cluster from acting as a hub or a spoke to a cloud-hosted cluster. Now, one of the major advantages of cluster-to-cluster is in terms of scalability and flexibility. It allows a hierarchical design, a hierarchical network design. You can create a hierarchical network with multiple layers of clusters. This allows you to scale your SD-WAN deployment to very large numbers of locations whilst maintaining a manageable architecture. In summary, VeloCloud's cluster-to-cluster interconnect provides a powerful and flexible way to build large, resilient, and highly performant SD-WAN networks. It simplifies the management of complex deployments and enables seamless integration with hybrid multi-cloud environments. So how do we create cluster-to-cluster interconnect? Well, again, this is done via the orchestrator. The first step is to create the cluster. Then step 2, assign clusters to the appropriate profile, with a profile being essentially a template. And then finally, in step 3, activate the cluster-to-cluster interconnect. At this point, permanent tunnels are built between the members of the cluster, providing that cluster-to-cluster interconnect. So in summary, why VeloCloud? Well, VeloCloud delivers on a scalable SD-WAN overlay, trusted by service providers and enterprise customers worldwide. The key architectural takeaways are we deliver on smart defaults, ease of deployment using zero-touch provisioning, link efficiency using our secret sauce dynamic multipath optimization, and secure on-edge security with EFS or enhanced firewall service, all delivered through a single orchestrator, that single pane of glass. Performance, resilience, and scalability are delivered through both our models, for instance, 41 and 5100 models, clustering, and high availability. And finally, flexibility, delivering on adaptability for diverse deployment scenarios across branches, data centers, and public clouds. I'd like to take this opportunity to thank you for watching this video. If you'd like to find out more, please feel free to contact us using the QR code in the link here, or please feel free to contact me directly on LinkedIn. Thanks very much.